Alright, what's up Algebra 1? Today we are going to be working with 0 and negative exponents. Okay, really our objective here is to be able to simplify expressions that have exponents that are either 0 or negatives. So we're going to go ahead and just jump into it right here off the bat. Okay, so we're going to look first at 0 exponents. Okay. Now 0 exponents are kind of interesting because, well, one that I like to look at to kind of be able to see how it works is tens, because tens are pretty easy to work with when it comes to exponents, right? So if we do 10 to the third, 10 squared, 10 to the first, 10 to the 0 power, okay? We're just going to look at 0 power for now, and we'll get to negatives in a bit. Okay, so if I look at 10 to the third power, okay, that's going to tell me 10 times 10 times 10. The nice thing about tens is that exponent is really just telling you how many zeros you're going to have. Okay, whenever that's positive or 0, that's just telling you how many zeros you're going to have. Okay, so for 10 to the third, I know I'm going to have 3 zeros, which is 1,000. And if you were to check that with this right here, you would notice that 10 times 10 times 10, your calculator is going to give you 1,000. Okay, so that works no problem. Then we continue on, 2 zeros, 1 0. Okay, so naturally, because of the pattern we're following, 10 to the 0 power should have 0 zeros, which would mean it would just be 1. Okay, so I think that's kind of cool, but that's actually what we get for any exponent to the 0 power, or sorry, any number to the 0 power, I guess, other than 0, which we'll look at here in a second, okay? But anything to the 0 power and you can just write this with me. Anything other than 0 to the power of 0 is equal to 1. Okay, so that's a good thing to be aware of and to know as we move forward. All right, so if you need to pause the video to finish writing this down, you can. I'm going to go ahead and move on. If we look at this, I think this is a really interesting thing. So if we look at kind of our patterns that we have everywhere, or in, I guess, 2 different places. So if we start with 3 to the 0 power and we decrease the base each time, okay, remember we've got the base is 3, the exponent is 0. All right, if we do that, we're going to get 1 all the way through, okay, because anything to the power of 0 is 1. Okay, but then if we look at zeros and we decrease the exponent instead of the base, we've got 0, 0, 0, and 0. Okay, so what that tells us, we have 0 to the 0 power equaling both 1 and 0. Now obviously something can't be equal to 1 and 0 at the same time, because 1 and 0 aren't equal themselves. Okay, so that tells us that whenever we have 0 to the 0 power, and I'm just going to highlight this in your book for you, okay, that should give you undefined. All right, 0 to the 0 power is undefined. If you try to type in 0 to the 0 power in your calculator, it's going to give you an error. It'll be syntax or domain error, I believe. But yeah, so that's what we need to know about 0 to the 0 power. Okay. All right, so now we're going to go ahead and move on to problem 1. We're looking at simplifying powers, and now we're looking at negative exponents. Okay, negative exponents are kind of interesting. Okay, and if we go back up here to the tens that we looked at earlier, we had 10 to the 0, so we went 3, 2, 1, 0. The next number in our pattern would be 10 to the negative 1, and then 10 to the negative 2, and we'll stop at 10 to the negative 3. Okay, Now, each time, because of this pattern, you can also see the decimal is moving. Okay, so it starts here. Okay, if we put 3 zeros every time, then it's moved forward 1, right? It's jumped to here. On this one, it's jumped forward another time from here to here. For 1, it's jumped forward. Okay, now if we go to 10 to negative 1, it's going to jump forward again. All right, so we've got 1, 0, 0, 0. It was here. Now it's going to jump here. Okay, so it goes here. So that will give us 1/10. Okay, and if you write 1/10 as a fraction, that gives us 1/10. All right. If we go one further, now we have 0.010. Whoops, not another decimal. Okay. There we go. All right. So now we have 1/100. And then this one would be 0.001, which would be 1/1000. All right. One interesting thing here. This is also the same as 1/10 to the first power, right? So what that tells us with our negative exponents is that we can go ahead and flip them to the opposite side, or the opposite side of the fraction, right? So if we turn this into a fraction, we have 10 to the negative 3 over 1. Okay, since it's to the negative 3, we can flip it. Okay, that moves down to the bottom. Sorry, I'm making a mess out of my writing here. Okay, we're just going to go here. 10 to the third power. Okay, that's what those are. These are the same. Okay, hope you like the little smiley face. It looks like a little bug. But anyway, so yeah, anything to the negative power, we can flip the side of the fraction that it's on. All right, so let's go ahead, and I'm going to erase all the 10s because we don't need them anymore. We're going to go ahead and look at that example on Got It Problem 1. Sorry, I said Got It Problem 1. I meant Problem 1, letter A. So we have 9 to the negative 2. Okay. For this one, we flip it to the other side of the fraction. So now we have 1/9 squared, which will give us 1/81. Okay. And then it also gives you B. Again, anything to the 0 power is just going to be 1. So you don't have to worry about that. All right. I don't know if we look at these. We do a little bit. But I'm going to go ahead and show you now. If we have 1/3 to the third power, again, negative third power, okay. Again, we just flip it over to the other side of the sign. So now we just have 3 to the third power over 1. I'm not going to write the over 1 part though. And that'll just give us 27. Okay. So yeah, that's how you do those. So we're going to go ahead. I'm going to have you try out Got It problems. Let's do A, B, and C. We'll just call it good there. Okay, so do those 3, and then we'll go ahead and move on at that point. All right, Got It problem 2 is the same thing, but now we are looking at variables being included here. Okay, so if we look at Got It problem B is a pretty good simple one to look at. So we have 1/x to the negative 5th. Okay, negative exponent means we just flip it to the other side of the fraction, which will give us x to the 5th, and that's it. Okay, so again, not difficult, pretty simple. I want you to go ahead and try out C, and I'm going to erase that. And then D and E. So don't worry about A and B. Those ones are pretty simple. I want you to do C, D, and E because those might be a little bit more challenging. So I want to see how well we can do. So go ahead and do that, and then we will start up the video again. All right. Lastly, we've got problem 3. Okay, there's 2 different methods we can do to solve this. Basically, it doesn't matter if we substitute our numbers in for variables first or if we simplify first, okay? It's totally up to you. All right, so I'm going to go ahead and we're going to do, there it is, and then we know S is 2, T is -3. Okay, so first, if I simplify first, that's going to bring this down to 3s to the third over t squared, right? Because that t is the part that has the negative exponent. Okay, so make sure you recognize it's only the t that has that exponent of -2. All right. And then from there, I just plug in. So that's going to give me, let's see, 3 times, we're plugging in 2 for s to the third power over t, which is -3, and that is to the second power. Okay, and then I can go ahead and simplify this the rest of the way down. 2 to the third power is 8. 8 times 3 is 24. And then -3 squared should give you +9. And if you want to simplify that, you can. That should be 8/3. All right. Okay, so that's if I simplify by moving the variables first. Okay. On the other hand, I can plug in first, and it's going to work out just as well. All right, so I have 3 times 2 to the third power, and then multiplied by -3 to the second power. Okay. From here, I'm going to go ahead and, so we have parentheses, right? If I follow order of operations, we have parentheses, but there's nothing to do inside the parentheses. So the next thing to do is exponents. Okay, I'm going to do those left to right. So I'm going to have 3. 2 to the third is 8. And then times, oh, and I forgot my negative exponent right there. So there we go. Fixed that. Okay. And then that's going to be multiplied by -3 to the -2nd power. Okay. That should give me 1/9, right? Because -3 to the second power is 9. And then I need to flip it so that's 1/9. Okay. From here, I can go ahead and simplify more. So 3 times 8 is 24 times 1/9. 24 times 9 is 24 over 9. And then that will equal, again, 8/3. All right, so you can see there, either order works for this problem. It doesn't really matter, and it's totally up to you. Okay, so go ahead on the Got It problems on this page. That's page 420. You're going to go ahead and try out problems A and B and C, actually. Okay, so go ahead and do those. And after you do those, that's going to be it for this video. We're not going to worry about problem 4 right now. So yeah, I will see you guys in class. And yeah, that is it. See ya.